right, we have been talking about verifying our trig identities. And so if we're looking at these fundamental trig identities, I would ask you to think about, what is your fundamental identity? Do you like what you see in the mirror? You know who you really are, not what other people see. You know the truth that is the real you. Does Christ like what he sees? Your true character is what you do when you think no one is watching. I say you think because God is always watching. So what is your fundamental, real identity? There's a line by Switchfoot that I love that says, "This is your life. Are you who you want to be?" So think about that. Are you? Are you who you want to be? And if not, God can help you change that. All right. So I have nothing new to teach you today, just practicing with those fundamental trig identities. And as we said, the more we do, the better we get. So we just want to continue doing them. All right. So for this first one, we've got secant squared minus 1 over secant squared. And you can see this is a verify because they're giving me the answer that I'm trying to get to. So step number 1, we said we were going to look for Pythagorean identities, which would be trig function squared, especially if there are 2 of them or it's a trig function squared paired with a 1. So we have a trig function squared paired with a 1. So if you look at your formula sheet and look at your Pythagorean identities, you'll see that secant squared minus 1 is the same thing as tangent squared. All right, so now we go back up to the top. And do I have any trig functions squared? Well, yeah, but I don't want to undo what I just did. Step number 2, do I have any fractions that I could combine or break apart? No. Step number 3, factor. If I were to put an x in for tangent and a y in for secant, I'd have x squared over y squared. There's no way to factor that. So I'm going to change everything to terms of sine and cosine. So remember that tangent is sine over cosine and secant is 1 over cosine. So when we are dividing fractions, remember we stay, change, flip. So the first fraction stays the same. Our division changes to multiplication and we multiply by the reciprocal. So we flip that cosine squared up to the numerator. All right, now you'll see that our cosine squareds will cancel. And that just leaves us with sine squared, which just so happens to be what we were trying to find. Now remember, you can only work on one side. You cannot work on this other side. You have to work until you get it to be equal to what you started with. Now, some people look at this problem and they're like, ooh, I'll cancel the secant squares right here. Well, the problem is you can't cancel things that are being added and subtracted. You can only cancel things that are being multiplied. If you'll notice, if I did cancel those, I would just be left with -1. Sine squared doesn't equal -1. So instead, let's look at how we could cancel those. The only way that I am allowed to cancel those is if I break that fraction up into 2 separate fractions. So, we typically are getting a common denominator and combining our fractions. What we're doing here is the reverse. It is that we are taking that combined fraction and breaking it back apart into the 2 separate pieces. All right, so now secant squared divided by secant squared is 1, and 1 over secant, again, is cosine. All right, so go back up to the top of your list, and we can see, okay, let's look for Pythagorean identities. Do you have a trig function squared, especially if there are 2 of them or it's paired with a 1? Yeah, I have a trig function squared paired with a 1. So that's almost always going to be a Pythagorean identity. And we know that 1 minus cosine squared is equal to sine squared by that Pythagorean identity. So totally different way to work that problem, but you see that you still come up with the same answer. All right, let's look at another one. So for this next one, do you have any trig functions squared? No. Step number 2, could you combine or break apart fractions? Well, yeah, I do have fractions I could combine with a common denominator. So the common denominator for 1 minus sine and 1 plus sine is 1 minus sine and 1 plus sine. So to get from here to here, we had to multiply the denominator by 1 plus sine. What you do to the bottom, you have to do to the top. And to get from here to my new common denominator, I had to multiply by 1 minus sign. So again, what you do to the bottom, you do to the top. Now, why do we get a common denominator? The whole purpose is so that we can combine our numerators, right? So let's do that. Let's combine 1 plus sign plus 1 minus sign. Now, the plus sign and the minus sign are going to drop each other out, right? And that would leave us with just 1 plus 1, or 2. All right, so now I have 2 over 1 minus sign, 1 plus sign. So if you're not sure what to do, remember, you can replace sign with a variable. Let's use x, all right? If I had 2 over 1 minus x times 1 plus x, and I was told to simplify, what would you do with 1 plus x, 1 minus x? You would FOIL it, right? So we're going to do the same thing here. We're going to go through and say 1 times 1 is 1. And then 1 times a positive sign is a positive sign. 1 times a negative sign is a negative sign. So the positive sign and the negative sign drop each other out. And then negative sign times positive sign is going to be a negative sign squared. All right, so we go back up to the top of our list again. Do you have any trig functions squared, especially if they're paired with a 1? And we do. 1 minus sine squared, we know, is cosine squared. So now we have 2 over cosine squared, and we know the reciprocal of cosine is secant, so to get that up to the numerator, we would need to rewrite it with that reciprocal relationship, and that is what we were trying to find. Now, something else that I would mention to you that we don't have over here in our list is that we can only work on one side of the identity, but there's a way that we can cheat and get around that, all right? I think it would have been very easy to get stuck right here on this step, because if you go through all of your steps over here, none of them will apply, and you get right here and you're just stuck, all right? So if you get stuck working your way down a problem, then go to the bottom and start working your way up. I know what the answer has to be, so go ahead and put your 2 secant squared down here on the bottom. You get a point for every line, so at least you get a free point, right? All right, then I could say, hey, I know secant's 1 over cosine, so that would be 2 over cosine squared. Maybe you can't figure out this line right here, and you don't get this one to match this, but now you're just missing one line. That's a -1, right? Whereas a second ago, you were missing half of the whole thing. But you may get to this point and say, okay, the 2's are the same, and I have 1 minus sine squared down here. I have cosine squared down here. I know cosine squared is 1 minus sine squared. How do I get 1 minus sine and 1 plus sine to be 1 minus sine squared? Is that possible? Oh yeah, if I FOIL them out, there it is. And so sometimes I can make those pieces fit together in that way. All right, here's another one. All right, so for this one, again, we have a trig function squared with a 1 for each of these. So step number 1, I'm going to look for Pythagoreans. So tangent squared plus 1 is a secant squared. And then cosine squared minus 1, the Pythagorean identity is actually sine squared plus cosine squared equals 1. I want just cosine squared minus 1. So first off, I need to subtract the 1 over to the left-hand side. So there's my cosine squared minus 1. Now I need to get rid of that sine square. I need to move it to the other side. So I'm going to subtract it over to the other side. And so cosine squared minus 1 then would be equal to a negative sine squared. Okay, so back to our list. Step number 1, do you have any trig functions squared? Yeah, but I don't want to undo what I just did. Step number 2, do you have any fractions? No. Step number 3, can we factor? Well, this would be like a squared times negative b squared. Not really anything we could do with that. So when all else fails, let's change it to terms of sine and cosine. So secant is 1 over cosine. So that gives me 1 over cosine squared times negative sine squared. So if I simplify here, 1 times negative sine squared is negative sine squared, and cosine squared times 1 is cosine squared. And now I know that sine divided by cosine is tangent. So that would give me negative tangent squared. And again, if you got stuck, you could always take your answer and bring it down here to the bottom and start working your way up from the bottom. All right, so I understand that these are very challenging, and we have a quiz on this tomorrow. So here is the deal that I have for you. At this point, we are to have memorized all of these: the reciprocal, quotient, Pythagorean, cofunction, even odd identities. So for your quiz tomorrow, I will only put 3 simplifies on there. Everything else will be matching formulas. All right. So that will help you out. It's not like you have a whole quiz full of the simplifies. So again, don't forget, quiz tomorrow.